We want to prove the identity tan theta plus 1 over tan theta is identical to 1 over sine theta times cos theta. When proving identities, there are three approaches that we can use. We can start with the left-hand side and manipulate it algebraically until we get the right-hand side. Alternatively, we could start with the right-hand side and manipulate it until we get the left-hand side. The third way is to start with the left-hand side and do some work, and then start with the right-hand side and do some work, and get the two to meet in the middle. In this particular example, I'm going to start with the left-hand side. So the left-hand side we know is tan theta plus 1 over tan theta, and we know the identity tan theta is sine theta over cos theta. So this is sine theta over cos theta plus 1 divided by sine theta over cos theta. If we look at this, we have 1 divided by sine theta over cos theta, so we're dividing by a fraction. If we turn the second fraction upside down and multiply, then it becomes cos theta over sine theta. So we have sine theta over cos theta plus cos theta over sine theta. We're now going to add these fractions. Just like adding numerical fractions, we're going to want a common denominator. If we had 4 and 7, our common denominator would be 28, because that's 4 times 7. This 1 would then get multiplied by the 7, and the 2 by the 4. If we adopt the same pattern here, our common denominator would be sine theta times cos theta. This sine theta would get multiplied by the sine theta, giving sine squared theta. The cos theta would get multiplied by the cos theta, giving cos squared theta. And we know that sine squared theta plus cos squared theta is 1. So we get 1 over sine theta cos theta, and we can see that that is the same as the right-hand side. And so we've proven our identity by starting with the left-hand side and going to the right-hand side.